So this is really neat. The idea underlying this isn't new, but the implementation they put on top of it is. Nvidia has released something called Diffusion Renderer, or really an update. I believe Diffusion Renderer was around before. I hadn't heard of it until now. But this new update is very new. Diffusion Renderer is a method of taking a video, analyzing it in a 3D way so that you can then relight it or insert objects and cast realistic shadows. Yeah, have you looked at this at all?
I've not seen that with NVIDIA. I know the new version of Photoshop is allowing things like that too. So you can take like an object. I think the one that I saw the other day was somebody took a rhino and then put it on a dark city street, and like all the lighting, shadows, and things that would make it match the texture and reality of that scene were able to be changed with a couple clicks.
Interesting. I wonder if it's doing this something similar under the hood here, because coming at this from my angle that I'm coming at this from is like a 3D artist making these kinds of things from scratch, not with AI. Lighting is a super complicated thing. There's a lot of different elements to like a texture. There's a lot of different elements to like a single shot. You have, and I've got it on screen here. This is such a visual segment, but I'm going to do my best to not make it unlistenable for our podcast peeps. When you have a scene, you have like the geometry of whatever's in the scene, right? So in this case, I'll just describe what's on screen. There's a sculpture. You got like the shape of that sculpture. You have the base color of that sculpture, right? And then you have all of the different light and shadow interactions cascading over it. And in the real world, like that's really easy to imagine how that's all working, but to recreate that in 3D, you have the geometry, that's one thing. The geometry has a base color, but then the way light reflects off it has to be calculated. And the way we typically do that is with ray tracing or path tracing in PBR, which is physically based rendering, where you literally will trace paths of light rays from the camera out to the surface and then off of the surface back to whatever light source, which is backwards from how light works, but that's how you do it for a picture. Otherwise, you have to simulate every light ray, even ones that wouldn't hit the camera. There's other approaches to that, but we can't get into that bit. A critical part of that is telling the light how to reflect off of the surface. And so for that, you use something called a normal map, which if you're looking at the screen, there's that that corner there that's all blue and red, which is just an image, and what's encoded in the image is the directionality of each pixel, basically, whether it's facing up, down, left, or right. Basically, it's a way of encoding the different directions light should come off of something as a way to get more detail onto a surface. And what NVIDIA has done with this diffusion renderer is a two-step process where you feed in a video, and then it estimates a normal map, which is that light reflection map, a depth map, which is how close or far something is from the camera, a metallic pass, which it has to do with reflectivity in a different way than normals, but this isn't about that, and roughness, which is also about like shininess and reflectivity. Similar to metallic, there are some slight differences between them, mostly about anisotropy and specular reflection versus more diffuse reflections. So what NVIDIA has created is essentially a pipeline where you can feed a video in, it will generate all of these different passes for each frame of the video, and then you can relight it using a different environment map, or HDRI, which is like a spherical photo that you would use to usually use those a lot in 3D to light your scene. It's like a photo surrounding whatever it is you're looking at and projects its color values and light onto it, so the photo itself acts as light. And using this model, you can essentially relight footage. So like you give it a video, and then it analyzes it frame by frame, and you can rotate and move the light sources around, insert new objects, and have it cast realistic shadows. And that, like, in and of itself isn't super new, but getting it at this quality is, because like photo scanning and photogrammetry has been around for a while. Have you ever played with Polycam or any photo scanning stuff, Perry?
I've not played with it. Yeah, I've seen other people, though. It's really cool.
But have you seen too, when you like take a photo scan of something, like all the shadows are there from when you scanned it, because it just has that baked in. So if you go and put a light on that side with the shadow, it's still going to have the shadow baked into the texture.
And that pops up in a lot of like deepfake detection techniques. Not necessarily all the automated ones, but when somebody's doing a manual forensic analysis, one of the things that they always want to do is like understand contextually, like where would the light source really be if this person is in this scene, and let me estimate where the sun would be so that I can pick out where their shadow would go and what direction it would be at, and all those kind of things come into the analysis.
Because it's such a complex process, right? Like surfaces are complicated, and like light reflection is complicated, and so it's been really hard to fake and simulate, and really computationally intensive. Actually, on my computer, running a Blender render in Cycles, which is a path tracing rendering engine, it uses more power than generating an AI image. My computer kicks up into even higher gear for that. I think I'm trying to remember what movie it was. I've been watching a lot of Corridor Crew recently. You know, they're the VFX team that does a bunch of cool stuff, and they were talking about this new technology that basically is like a depth pass in the camera that makes it easier to composite CG elements into a real world scene. But the way that works is you have a camera that's actually recording the depth pass, and then you have these even larger video files that contain this extra channel for depth of each frame, and that's obviously huge and like inaccessible to anyone beyond James Cameron level directors and filmmakers. So
for the next year.
Yeah.
Yeah, I mean, so every iPhone camera has a depth sensor in it, right? So technically there's the ability to start to do some of that now, and lots of different apparatus even have like LiDAR built into them now.
I actually think the iPhones are using LiDAR too.
Yeah,
if I'm not mistaken.
I think you're right there. So that's essentially what you need to do a lot of that.
To get the depth scan, but then to the resolution required to accurately then simulate light on top of it is what is pretty wild. And I think why those cameras are more expensive, because you need an array of LiDAR sensors and a really high resolution like LiDAR scan to make it possible. Because otherwise you'd end up with like weird shadows and jaggies and like slight things that aren't quite right. So with this, rather than actually like taking the shot into a 3D software afterwards, this is both an inverse and a forward renderer where you can feed it a video and then feed it an HDRI and some parameters, and it will just do both things in one pass. They put a great write-up on their research.nvidia website with a lot of cool visual examples that I'm just kind of scrolling by. It's definitely worth poking through and looking at. It's very cool. But here's an example I'll put on the screen where they have an input video of some cars driving down a road. The shadows are cast sort of off to the left. And then they have 4 versions of the scene relit with different HDRIs, so the lighting conditions change a little bit. HDRI being the spherical environment. And then like in the 4th one, the shadow direction is completely in the opposite way, and everything looks photoreal and crisp and clean, which is something that you struggle with when you do like path tracing to camera lens and whatnot. They show that in a different example where the rays that are cast from the camera can only be so good. But using these neural networks to imagine what the geometry of the scene might be like and infer that, they can create much more detailed models for relighting, and you avoid a lot of those constraints.
That's really cool.
Yeah, and it's you can download it right on GitHub, but all you need is an Nvidia GPU with at least 16 gigabytes of VRAM, recommended to have greater than 24 gigs, and at least 70 gigs of free disk space.
Oh, wow. Okay.
And it looks like their instructions are about sort of running examples and just feeding, I was trying to figure out how much you could get out of this easily, and it seems pretty complex. Like you can feed it an HDRI and tell it to relight it with that. But as far as like precise control from the command line, I don't really know how you would do that for like object insertion and stuff like that. So I'm sure there's going to be more artist-focused tools that come out on top of this. But just the relighting capabilities, like delighting and relighting scanned scenes just from video, pretty freaking cool. And like at this quality level is something we haven't seen yet. I think it's an awesome use of
really cool
video diffusion tech.
Absolutely. And I think there's so much work being done on the video front that it's going to be really interesting to look back a year from now and see where we are, because it seems like every week something new and cool is coming out.
Yeah. And as these world models get better at simulating, or not even, I don't want to use the word simulating, because when you simulate something, you go through step by step what's happening, just like the path tracing.
Right.
In this case, it's just really educated guessing. It's data-driven processing rather than like physically simulated. But it is still a way of capturing and understanding and recreating and I guess simulating physics, right? And as those world models get better, as we're going to talk about in just a moment, that's also what powers like robots and automation.
So why don't we go ahead and get into that?
All right, we'll take a quick break. We'll be right back. Don't move.